Now, let's look at the question. After we have gathered all the necessary things we needed to know about this particular question, we said the question said 5 ohms resistors connected in parallel have a potential difference. We have already know what I mean by potential difference. Have a potential difference of 60 volts applied across the combination. Then they said full stop. The current in each resistor is what they ask us now, the current in each resistor. Before we go into solving it, let's look at this format we needed to know. This 3 resistor in parallel. 3 resistor in parallel. This is R1. This is what? R1, R2, R3. This is R1, R2, R2, R3. They are in parallel. How did I know they are in parallel? How will I know that these 2 or 3 or more resistors are in parallel? How will I know? For me to know that 2 or more resistors are in parallel, this different current will flow through them. Means that different current or different charge will flow through them. The current that flow through them are not the same. Immediately the current that flow through them are not the same. I know that those people are connected in what? Parallel. Look at it. Look at this current now. The current are going in. Are you going to say? It flow. When the current flow from here, this is the current produced by this battery, is flowing now, going into the circuit. When you get here, what will happen? Man, look at what will happen. This current will split. Part of it will flow to this place. Part of it will flow to this place. Part of it will flow to this place. And this is what happened. This is current produced by this battery. It's entering into the circuit. Getting to this point, look at the point. Then some of the current will flow this way, which I call what? Current 1. Some will flow through this way, I call it current 2. And some will flow like this, call it current 3. And this current will come back here and come back to the what? The battery. Look at it. This man will come here and wait. This one will come and wait. This one will come and wait. They flow and come back to the battery. So when I have a different current flowing through a what? A resistors, 2 or more resistors. 2 or more resistors. When I have a different current flowing through what? 2 or more resistors. Those resistors are connected in parallel. Have you seen how I will know that a resistance is connected in parallel? When different current flow through them. The current that flow through them splits and what? Different current flow through them. I will say they are in what? Parallel. Noted. Then now, this man is voltmeter, which we use to read the voltage drop across this R1. This is voltmeter 2, which is used to read voltage drop across this resistor 2. This is voltmeter 3, which is used to read voltage drop across this resistance what? 3. But let me come again. This is voltage 1, voltmeter 1. I remember it 1, voltmeter 1. It's used to read the voltage drop across this what? The resistance 1. That's the what resistance 1 can consume, the current which it can consume, amount of the food is going to eat through this current. While this V2 is voltmeter 2, used to measure the voltage drop across R2. While this V3 is what? Voltmeter 3, used to measure the voltage across this what? R3. Then let me shock you. The voltage drop across this man and voltage drop across this man and voltage drop across this man are the same. If this voltage drop across this man is 20, this one will be 20, this one will be 20. That's the properties of what? Parallel connection. In parallel connection, voltage drop across each resistor are the same, but current that flow through them are not the same. I'm coming again. In parallel connection, the voltage drop across the what? Each of the resistor is the same, but current that flow through them are not the same. Then we now come back to say this voltage drops across each of these is equal to the what? Supply voltage. This is supply voltage. Just like at your home, you bring out your wire and connect to the what? High tension, low tension in your home. Another person from his own house will bring his own what? 16 mm and connect to the low tension. All of us begin to connect to low tension. What we are connected, we are in parallel to each other. So we now see, look at it. Look at the tension. This man is connected here. Look at the voltage. Is supply here. This man hooked to this. This man hooked to this. Look at the voltage. You could call what? Potential difference. Look at potential difference this man will produce. hook here. Look at the end, look at the end. And this man now tap from it. This man tap from it. This man tap from it. So the voltage supply are the same. Voltage across each of these people are the same with what? Voltage supply. And that's what I started here to note it for you. Come over here. I noted this to you. Said V, which is voltage supply, is equal to voltage drop across resistance 1 and is equal to voltage drop across resistance 2 and equals to voltage drop across resistance 3. And I come back to tell you why the voltage drop across resistance 1 is voltage drop across resistance 1 is equal to resistance 1 times current 1. Look at it. This current now times this man will give you voltage drop. This is what this man will read. Are you get what I'm saying? That's what voltmeter 1 will read. Voltmeter will read 1 will read current times R1. Voltmeter 2 will read what? Current 2 times R2, which is voltage drop across R2. Then voltmeter 3 will read what? Current 3 times R3, which is voltage drop across what? R3. Then we will now say it again that since this man is equal to this, we will now carry this man to substitute here, carry this man to substitute here, carry this man to substitute here. We have this that V is equal to what? Current 1 times R1 is equal to current 2 times R2 is equal to current 3 times R3. Since this man is equal to this, look at it. I remove this man now, carry this man, put here, look at it. I remove what? This man now, carry this man, put here, have this. I don't know. I remove this man now, carry this man, put here, have this. Have you seen it now? See the V is equals to what? Voltage drop across this and voltage drop equals to voltage drop across this equals to voltage drop across this. That means voltage drop across this man and this man and this man are equal to the what? Voltage supply. Then another condition, we say that current are not the same. Since current are not the same, the total current, which is this, look at the total current. Come over here. Look at the total current. The total current is equal to current that goes to the what? R1 plus current that goes to what? R2 plus current that goes to what? R3. That's what we say. Current, total current is equal to current 1 plus current 2 plus current 3. Will give me what? The total current. Because this total current is what splitted here and go here and go here. And when we add it to up, it will give us the total what? Current that what? Flow. Then now we'll come back here to tell you that current 1. Pay attention seriously here. That's where Jam and Wayek will confuse you. Current 1, which is this, are not equal to current 2. Current 2 are not equal to current 3. This man are not equal to current 2. This man are not equal to current 3. They are not equal. Then they will only be equal. Pay attention. This man will be equal to current 2 and current 2 will be equal to current 3 only if R1, R2, R3 are the same. That's the condition they give us here. Are you following? This current 1 and current 2, current 3 will be equal to each other only if R1, R2, R3 are the same. Look at it. They say 5 ohms. That means the resistance are equal. That means R1, R2, R3 are the same, which is 5 ohms. Therefore, current 1 will be equal to current 2. Current 2 will be equal to current 3. But let's go to what? The question. Come over here. We'll come back to the question to solve it. Look at it. Resistance in parallel. 3 resistance, which is 5 ohms, is in parallel. That's what they asked us there. First, 5 ohms, 5 ohms, 5 ohms. You see that the resistance are equal. That's resistance 1 is equal to resistance 2 and is equal to resistance 3. Therefore, current that flow through this man is same thing as current, this one, current 2. And this current 2 is same thing as current 3. This current 1 is equal to current 2. Current 2 is equal to current 3. Reason, because these resistance are the same. The same current will flow through them. Then now, let us go into calculation. We now say the voltage across it, the potential difference across it is what? 60 volts. Look at it. Potential difference across it is 60 volts. We'll stop. We'll put it here. But let's say, we'll now come to what? Voltage drop across what? This man. This 5 ohms. I will say current 1 times R1 is equal to what? 60 volts. Because this voltage drop across this is equal to 60 volts. Voltage drop across this man is equal to 60 volts. Voltage drop across this man is equal to 60 volts. And I choose this one. Say voltage drop across what? This man, the first one. I say current 1 times R1 is equal to 60 volts. And I said making current 1 subject of formula become what? R1 at 60 volts divided by R1. And what is R1? 5 ohms. I put 5 ohms. 5 ohms divided by 60. It gave me 12 ampere. It give me what? 12 ampere. Because R1 is what? 5 ohms. And the current, which is this, which I'm looking for, is equal to what? This voltage divided by what? R1. And R1 is what? 5 ohms. It give me 12. Or I can choose to say voltage drop across this, which is what voltage drop across what? R2. And I say V2 is equals to current 2, that's R2. And the same thing is equals to what? 60 volts. And I say equals to. And I'm making what? R2 subject of formula by dividing through by what? R2. I will now have R current 2 equals to what? V2 divided by R2. How did I do that? By dividing 2 by what? R2. The same thing I did here by dividing 2 by what? R1. I will now divide this one by R1. Divide this one by R1. I have this. R1 dividing this current 1 R1 will give me current 1. Then what I will have here is 60 divided by R1. Then what is R1? 5 ohms. I put it here divided by 60 give me 12 ampere. Or somebody choose to say this one. I said what? V2, which is voltmeter 2. We read what? Current 2 times R2. And it will give me what? The same thing as what? 60 volts. And I say making what? R and current 2 subject of formula. I will divide through by R2. Dividing through by R2, I will have now this divided by R2 will kill itself, giving me towards current 2. Then V2 will be divided by R2. And what is the V2? The same as what? 60 volts. I will now say 60 volts divided by 5 ohms will give me what? 12. Or you can also choose it to be what? Again, choosing this man, it will still give you something, the same thing. I'll say V3 is equals to what? Current what? 3, R what? 3. And making R current 3 subject of formula divided by R3, I will have current 3 is equals to what? V3 divided by what? R what? 3. And what is the V3? V3 is same thing as what? 60 volts they give me, which will give me what? 60 volts. And R3 is what? 5 ohms, which is, look at it. And that will give me what? This is equals to what? 12 watt ampere. And when you add this and this and this, add this total current, it will give you this total current that is here. And if you want to know, it will give me what? Total current that is here. Look at it. If I want to add it now, it will give me total current that is here. I will say total current equals to 12 volts plus 12 ampere plus 12 ampere plus what? 12 ampere. And that will give me what? 36 watts. 36 watt ampere. That's the total current. And if I want to confirm this, whether this total current is the same or whether this total current works here, I want to know. I can now calculate the what? The total resistance here divided by what? The voltage. My option is option C. That's my answer. Look at the option there. Option what? C is my what? Answer. Look at it, which is what? 12 ampere. And what we have here is what? 12 ampere. Thank you. If you have not subscribed to this channel, endeavor to subscribe.